Hello, my name is Brady, or Wandering Sounds on Hackster and GitHub, and what you see in front of you is NXP's i.MX RT1010 EVK, which is a development board for a dirt cheap and very powerful i.MX RT crossover MCU. I've got something pretty neat to show you. This board is running speakEZ, which is a demo application. It has a lightweight polyphonic wavetable synth and vocoder solution wrapped up in this tiny package. I'm hoping to show you its demo features now and encourage you to flash your own board, try for yourself, have a blast. Assuming you don't own a MIDI keyboard, we're going to start off with the basics and then go into the MIDI setup. So first things first, this is the audio out, TRS jack, stereo, but in the case of this demo it's just using mono audio. We need power, so that's going to J41, our debug USB port. And then for later on, here is J9, our USB OTG connector. These two buttons are going to be useful. The button on this side is the user button, switch 4, and on this side is the reset switch. If you press the user button, you'll see that green LED light up, and the reset switch will start us back to square one. So, no MIDI keyboard. How do you play with this thing? Well, hold down that user button, hit the reset switch, and you'll enter into a series of chords. There are 8 chords total, each one composed of 8 notes. And this progression kind of helps you get a feeling for what the vocoder sounds like, and maybe what kind of music would benefit from using a vocoder like this. So I've had a lot of fun working with this mode as I've been debugging and prototyping the code, and I recommend, even if you don't have a keyboard, go to the Hackster or the GitHub page, download this, flash it to your board, and try it out. I think it's been a lot of fun. Now, on the other hand, in front of me I've got an Arturia key step. If you have a MIDI controller, let's try this out. So this is important. Most MIDI controllers are expecting a USB Type A female connector. This is an adapter for USB OTG so that we can connect with this board. I'm connecting the cable to the adapter first, then I'm connecting it to the board. If you do it the other way around, you could possibly damage that jack. So I'm going to plug it in now. It'll supply power to my MIDI keyboard. Even a really big one I'm using, a Panorama T6, has no issue getting powered from this EVK. And in this setup, we can similarly play chords, but we can play chords that we define, changing tone, and the interesting thing about this, the user button lets you switch to an alternate sound. So press it once, it goes to another wavetable that has quite a gritty, harsh sound, but the vocoder plays off of it really nicely. Press it again, you're going to go to a synth, a sine wave, which is pretty clean and pure and sounds almost murky. Vocoders need a little bit more character, so triangle wave is closer. This is going to get us some more harmonics and sounds closer to what a vocoder normally sounds like. But the default, one of our 4 wavetables built into this demo, is the saw, which sounds like a traditional voice. And if you're going for the robot vibe, then this is a good place to start. So I think that this is an interesting musical tool. It's going to be useful for all kinds of audiences, those that are just starting out with audio that maybe want to understand how some of it works under the hood, or those who are looking for maybe an interesting musical device and want to use something real-time in an embedded form factor that is absolutely microscopic. For consumers and makers and manufacturers alike, I think this speakEZ demo and in general this technology is going to be very useful for you. So I've been having a lot of fun with this. To learn more, please check out my Hackster project linked below, or head to github.com/wandering-sounds/speakEZ, also linked below for the repository. Thanks very much, and take care.